Okay, question number 1. If the samples values are paired, which means they kind of depend on each other, right? Let's say we are saying some plant, how well it grew last year and how well it grew this year. So those are paired, right? So you can compare them. So such samples we call dependent. Second one, listed below are body temperatures from 5 different subjects, measured at 8 a.m. and then again at 12 a.m. There we go. Those are paired and those are dependent samples. Find the value D bar and SD. Okay, D bar is a mean value, average of these two data, temperature of these two dependent data, temperature at 8 a.m. and temperature at 12 a.m. To make it, to explain to you better, so when people, let's say, are living by themselves, they are single, so every person has their own expenses, right? But when they start living together, so everything is kind of mixed up. Everything is belongs to together. The same thing here. Since our data are samples are dependent, then average it's gonna be mixed up. Belongs to both of them, so it's together. This data create average, a D bar, and SD is a standard deviation for these samples. Okay, all right. So let's start working now. Formula for standard deviation. Because formula for standard deviation is gonna include also average, so I'm starting from there. So formula for standard deviation is equal sum of D minus D bar squared divided by n minus 1. And we take square root. Okay? And D bar is equal sum of D, I'll tell you what D is, sum of D divided by N. Okay? So, to start solving, this is what we're gonna do, and this part I have in Excel, on Excel template. So first thing first, what we have to do. So first of all, we are going to go to Excel spreadsheet and fill out the gray area, the temperature at 8 a.m., all these 5 data, and temperature at 12 a.m. Also in there. So sample size, you don't need to count and place in there because I have already placed also as a calculator. And don't touch anything else. You just collect your average between between these two temperatures and standard deviation between these two temperatures, and these answers are highlighted in light yellow color. Okay, so the key part of understanding in this assignment is when pairs are dependent, where the samples are dependent, then the average standard deviation you are going to get from both of them. So it's going to belong to both of them, average, not only for one sample, but two samples together. And And to calculate the average, it's not like you add all of these the elements from temperature 8 a.m. and 12 a.m. and divide by n. No, you add their difference. You add their difference. D is the difference. So you will see on template, but real quick to explain, here is difference gonna be, and this is gonna be your D. So let's say 97.6 minus 98.2, 99.5 minus 99.9, and so on. And summarize this difference of, okay? And then divide by amount of element, which is in this case is 5. And the formula, it's approximately similar to standard deviation for one sample, normal distribution, but still you get involved with this D, which is a difference between two of them. And the D bar you already know by that time. Okay, so this is this much about this question. So let's move to next question. What design principle is stressed for experiments or observation studies? So practically what is asking, which one is better to use, dependent or design principle, meaning what is better to use, dependent samples or independent samples? To when you can get better information. Better information, understanding, we always get by comparison, right? One thing to another, which that means this thing have to be to in what way would be easier to not easier, but we will be able to compare samples that are dependent on each other or samples that have nothing to do with each other, they are independent. Of course, dependent samples, and obviously they are dependent, where the data also are going to be paired, and this case is better than using independent, right, samples. So dependent samples. Question number 4. Which of the following is not a principle of making inference? So let me repeat myself so I can explain. So here is the thing. When we test the null hypothesis on mean difference that is equal 0, right? Remember, we are doing mu1 is equal mu2. So it's not equivalent to determining whether the confidence interval includes 0. Confidence interval, it's coming from the elementary statistics, the one you already learned. Just to remind you, confidence interval, it tells you with what percentage you are confident for happening this or that event, or something will be done. Okay? So if the confidence interval, and that is a confidence interval that you choose, includes 0, that you believe will have value. Sometimes 0 has value, sometimes 0 doesn't have value, right? 0 degree on a scale, that means the scale is balanced, right? Or 0 degree on conditioner, but in some other cases 0 doesn't mean anything. So if you believe it has a true value, okay, then we consider it as significant, all right? And therefore we can say that the principle that the mean difference is equal 0 is not going to be equivalent of determining the confidence interval includes 0, because in hypothesis test, when we say 0, that has a meaning, right? It's equal, mu1 equal to mu2. In the case of confidence interval, not necessarily has to have meaning. That's what it is, okay? So moving to question number 5. Okay, I would like at least to write down the formula so you would know the formula. So let me see. Test statistics is equal D bar, which is average, minus mu. The formula, the test statistics is similar to previous test statistics formulas, but the interesting part of it here is the standard deviation to calculate square root of n. So standard deviation is equal square root n sum of d squared minus sum d squared minus n times n minus 1. Okay, and we know that d bar, to find out d bar, which is average, that is equal sum of differences between paired data divided by n. Now all this could be done in Excel spreadsheet, but I think calculator would be 1, 2, and you got the answer. All right. So in p-value, we draw conclusion based on the rule that we already know. If p-value, not rule, but result of the facts, that p-value is the probability of, if p-value is less than or equal your alpha, then we reject null hypothesis. So since in our case, p-value is greater than alpha, then we fail to reject null hypothesis. Null hypothesis, and we say there is not sufficient evidence to support the claim. Okay, the rest of questions starting from the question the B, and actually test statistics also. I'm going to show you on the StatCrunch, no matter how much I was avoiding to use StatCrunch, so it's not going to work, so I'm going to use StatCrunch. So please follow me, and you can solve your confidence interval and test statistics on StatCrunch. Okay. Okay, question 5, I'm going to use StatCrunch, and I opened a view example, so you can write down the answers that we need to get from StatCrunch, compare and see that it's working properly for you. In this problem, we have to find test statistics. In this case, I see test statistics is equal negative 0.09, and p-value is equal 0.533. Okay, let's go to StatCrunch. I'm showing step by step how you're gonna do. Clicking on this rectangle, opening in StatCrunch. Okay, next you are going to click Stat, and we are using T-Stat, and we choose paired. Okay, now in sample 1 column, we use height of president, the first sample, right? Second one, sample 2, it's going to be height of main opponents. So here by this null hypothesis we have, I will explain null hypothesis. Yeah, I think I explained already, but I'll double check. If not, I'll go over. Null hypothesis in this case, it's going to be equal, but alternative is going to be greater, because the problem says that the presidential candidate have advantage if they are taller than main opponent, which means it's going to be left tail test. Okay. So, and that's it. We don't touch anything else. And we click, let me see, here it is. I have compute here, but you should have at the bottom compute. And here I have my information. Here is our pair T hypothesis test. And you see here T stat is negative 0.085, which was negative 0.09. We rounded. P value we have 0.533. Okay? Next, we are going to find confidence interval for this database. So what we're gonna do again, and it's asking for 90% confidence level. So for one tail, we had alpha is equal 0.05. So here we are going, it wants, it says it corresponds to confidence level of 90%. They are taking two tail building because confidence level, low level and upper level, right? It's going to be two tail. If alpha would be 5% for two tail, then we just would be confidence interval would be 95. But because it's for one tail, so 5% times 2, it's going to be 10%, and confidence level will be 90%. So let's get going. So again, opening in StatCrunch. So clicking stat, T-stat, I'm choosing paired, and then I'm choosing first column, choosing second column, main opponent. Okay, this time instead of hypothesis test, I am going to use confidence interval with a level of 90. Okay, and moving to compute. And what am I getting? I'm getting the result that is matching to our given information in example. Let me see which one was that. Here it is. See, negative 8.1. Mu d is greater than negative 8.1 and less than 7.5. So mu d, it's average for paired samples, right? So moving here, look here, L limit, upper limit. So this is low limit, negative 8.14, and upper limit 7.48. Okay, so once we have it, we are good, and we finished the StatCrunch operation. So from here, we can draw the conclusion since confidence interval contains 0. Why? Because from negative 8 to 7 it goes through 0, correct? Then we say that it's fall to reject. Okay? Null hypothesis. This is how it works with matching with paired samples. So if confidence interval contains 0, then we fail to reject null hypothesis. Write down. If confidence interval does not contain 0, then, which means, let's say from 5 to 10 positive, right? There is no 0. Or negative 5, negative 10. There is no 0 involved there. So therefore, we reject null hypothesis. Okay? Okie dokie. Moving to next question. Question number 6. Listed below are numbers of words spoken in a day by each member of 8 different randomly selected couples. Complete parts A and B. Okay, so here we have male and female samples. So since we are going to test, they are dependent samples, and we are actually, yeah, they are paired in this case because we are comparing words and for each member. Okay, so we are going to use mu d, right? Mu d is average for between these two. It's a difference, average of differences, which means element of male minus female, right? And we are going to test if male, using the words less spoken by male minus words spoken by female, it's going to be greater than 0 or less than 0. The claim is that males speak fewer words in a day than female, right? Okay, so this is, we are going to write down the following way. So it's going to be, if mu d less than 0 is false, then mu d, it's going to be greater or equal 0. It's going to be our true, which is going to be our null hypothesis, right? So let's write down. So null hypothesis is going to be mu d is equal 0 when we accept as a true. And alternative one, it's going to be mu d is less than 0. Okay, so we have, this is our claim. And our claim is left tail test. Okay, so next thing we need to find test statistics and p-value. So let's move to our stat crunch, and I'll open a view. So why am I doing in the view? So you can see how much is the value in the viewing example and compared to stat crunch results. So to make sure you are doing operations correct, and then move to your problem. Enter the data to in your problem. So let me see. Here it is, our standardized test statistics. T is equal negative 0.44 and p-value 0.366. Let's go. Opening in StatCrunch. So stat, I'm choosing stat paired, right? First column is male, second column is female. And here an alternative, I'm choosing less than, right? Claim is that men speak fewer words than women, which is, you know, to my opinion, such things we don't have to even test it. It is obvious that women are talking more than the men. Okay, let's click compute. There we go. T-stat, we got negative 0.4426, p-value 0.3357. And that's exactly what we had. P-value 0.3357, which is 336. Okay, so next we need to find, I believe, we need to compare our p-value. We compare to significance level, and our significance level is how much? Was 0.05? 0.05, and our p-value is 0.05 is our left tail, and our p-value is 0.336. So what we can conclude that our claim speak fewer words in a day than female, right? So why? Because p-value is our p-value, where it was 0.336, is greater than alpha for left tail, right? 0.05, and that means we fail to reject null hypothesis. We fail to reject null hypothesis. We reject alternative. So which means there is not enough evidence to support the claim. Moving to B. So we need to construct confidence level. Let me see where is confidence level, and we can test on StatCrunch. Negative, here it is. negative 9021 and positive 5604. Let's move on. So I'm closing this, opening, paired, and then we have male, we have female, and in this case we choose confidence interval. Since it's a one tail, then for two tails confidence going to be 90, because we are taking it has to be between, right? And that is going to be our confidence interval. We can't include tail in our confidence interval. That's why we cut both tails, right? Which is going to be 10% if one is 5%. And we use our confidence interval. So where is my compute button? Here it is. And I got negative 9020 and 5604. There we go. We have it. All right. So what we can say from here, we have answered all questions or not? Let me see. Okay, since confidence interval is going through 0, right? Again, then we fail to reject our null hypothesis. Okay, moving to question number 7. Several students were tested for reaction times in thousands of seconds using their right and left hands. Each value is the elapsed time between released a strip of paper and the instant that is caught by subject. Results from the 5 of the students are included the graph to the right. So as you can see, it's gonna look like direct line, right? Proportion. So use alpha equal 10%, 0.1 significance level to test the claim that there is no difference. So no difference, it's going to be mu d is not equal 0, and accordingly null hypothesis mu d is equal 0 in reaction between right and left test. Okay. First thing here we need to find, to test it, we need to know our standardized test statistics. Okay, while I'm going to show you in the StatCrunch how to do it, which is going to be the same way actually. So, and that's going to be formula T that is equal, this is average of the sample, the difference, average of difference between samples, minus mu d, that's average of population means, divided by standard deviation of these two samples, and divided by square root of n. So we need to find d, which is our difference, and then find the average. So I prepared in Excel spreadsheet d bar, so you can get d bar. Let me see, although you have it on Crunch also, it's negative 17.4. Let me open. Okay, so we can have other conversation. So this is our table, left hand, right tail, right hand, and if you provide imaginary line, you will see it's going as a straight line, right? Okay, so straight line, that means it's normally proportional. This line is proportional, input and output, or proportion between, direct proportion between the left hand and right hand. So now let's draw the, not draw, but state our hypothesis. null hypothesis is equal, alternative is not equal. Why? Because we are its claim is, let me see, several students were tested reaction times using their right hand and left hands. Okay, so results from 5 of students are included in the graph. Okay, so we are testing if right hand it can work the same way as left hand, or they can't. That's why we are going to test equal, not equal, which is going to be to tell. So, and at the end you will see exactly what I was saying. With 5% the question, 5% significance level to test the claim that there is no difference between reaction. Okay? So, and our claim is going to be null hypothesis, no difference. Null hypothesis is going to be our claim. Let me write down this here. Oops. This is our claim, that there is no difference. Okay, so now let's continue. Once we have it, I'm going to move to open our StatCrunch. And by the way, here it's asking to get D bar, which is going to be sample mean, and asking to find also standard deviation for the sample mean, which I placed in the Excel spreadsheet, so you can see it, how to calculate it. And but for T critical, I am going to place into StatCrunch. Okay, so let's go. Precise. We're going to work exactly the same way. So stat, T-stat, and paired. We have right hand, we have left hand. So equal, not equal. This time we don't change anything, and we are completing, and we get 17, negative 17.4. That's a mean. In our standardized test statistics, negative 6.95. Let's go check. 6.95. Here it is. We have it. Okay. So, and the next question we need to find test statistics we found. Now we need to figure out, identify the critical values. Okay, for critical values, we know what to do, right? Our alpha is how much? 0.05, I believe. Let me, where is the beginning? For the problem, oh, here it is, 0.05, yes. Since it's at two-tail test, so we are going to take alpha half, right? It's going to be alpha half here. Or we don't have to, I guess this is a t-test. We just go straight to t-test and take the alpha for two-tail. And we have how many? 1, 2, 3, 4, 5. Is that what it is? 1, 2, 3, 4, 5. So degree of freedom will be 4, right? Degree of freedom is going to be 4. So you find here degree of freedom 4 and alpha to tail. And you should get, let me see how much. T critical should be plus minus 2 point. T critical should be plus minus 2.776. Okay, let's go check it. Yeah, here it is. T plus minus 2.776, the last line. Okay, So we have the T critical. So from here, what do we have to do? We need to draw conclusion. So we can compare T critical to our, rather saying standardized test compared to our T critical. And what we can see, our standardized test is negative 6.954, and T critical is plus minus 2.776. So does it fall negative 6.954 in healthy area? I would say what? Test statistics is in a critical region, right? Because it's going to fall in the rejection area to the left, right? It's less than negative 2.776. Therefore, we are going to reject our null hypothesis at alpha is equals 0.05. Okay? So, and from here we can say that there is not sufficient evidence to reject the claim, since there is no difference between reaction between right left and left hands, right hands and left hands. All right. From here, questions from 8 to number 15, they are exactly the same, so you can plug into Crunch and start Crunch and collect the values and draw decision. I tried to avoid start Crunch so we could have some hands-on, but I spent today half of a day doing formulas and everything, but realized that we are not going to make sense out of all these crazy calculations. That's why I just moved everything to start Crunch. So if you have any questions, obviously you can contact me. Weekend, no weekend, doesn't matter. We are working this month together. I know you will be working on weekend, so do I. And I am moving to prepare the quiz and test, so it will be posted today. Okay. Let me know if you have any questions.